The next thing that we're going to learn how to do is how to graph something by using what are called the intercepts. The reason it's plural is because a line can potentially have two intercepts. It's possible to have one. Usually you have two. An intercept is this place, I'm going to say the point, where the graph crosses an axis. Which means typically you have two of them. You have an x-axis and a y-axis. So if I were to draw a Cartesian plane here, this is the x-axis. This is the y-axis. And I'm going to give you something that's not a line. I'm going to give you a goofy graph here. I'll give you a graph that goes like this. This goofy graph here touches those axes in a few spots. For example, it touches here, and here, here, and here. I'm looking for any place where the green line and the black line intersect. So how many times does that green wavy shape touch the x-axis? 3. So it has 3 x-intercepts. And how many times does it touch the y-axis? Once, so it has 1 y-intercept. Now the reason it has so many x-intercepts is because I drew a curvy, weird shape. When you're talking about lines, there are 3 possibilities. So I'm going to draw 3 Cartesian planes here. One possibility is you have both, an x-axis and a y-axis. So there's one and there's one. This one has 2 intercepts. That is the most common. Most commonly, you have 2 intercepts. It is possible to only have 1 intercept, where it only touches one of the axes. What would that look like?
Which goes right down the middle of the origin.
If it went right down the middle of the origin, it would touch twice, wouldn't it?
Diagonally on the origin.
Right, but then it would touch twice. If it went through right here, like let me draw another line here. If I drew a line that did this, that has an x-intercept and a y-intercept is just the same intercept. So we'll go ahead and say, because I like where your head's at, we'll say 1 intercept for that one, but it does touch both. What I meant with my question was, is it possible for them to only touch one of the axes? Could a line touch only the x but not the y?
Yeah.
Oh, okay, great. There's one. What if it goes straight up and down? This has an x-intercept only. And what was the other one?
Y-intercept.
What would that look like? Going across horizontally. So when you walked in tonight, I handed you a paper that has 3 different graphs on it. I want you to go ahead and pull that paper out. And let's just practice identifying the axes. Not the axes, the intercepts. So right here, how many intercepts are there? 2. Where are they?
Like the points? Or
The points. So the cross is here. What point is that?
2.
Be more specific.
0,
0, 2. And it's got one right here. What's that one? That's 1, 0. So this one has two intercepts at 0, 2 and at 1, 0. Is 0, 2 an x-intercept or a y-intercept? This is a y-intercept. Which makes this the x-intercept. Okay. What about, this isn't even a line. This is the sort of curvy U shape.
There's a bottom and top.
Yep, got one right here. Where's this
But
one?
it doesn't intercept. Well, except for that one.
It just one.
Oh.
0, negative.
That's 0, negative 4. Is that an x-axis, x-intercept or a y-intercept?
Y.
That's a y-intercept. And you said it only intercepts the one time. It technically does right here. It doesn't cross it, but it touches it, which is all we want, just for it to touch.
Oh.
What are the coordinates there?
-2, 0.
Yeah, it's an important distinction. That's an x-intercept. Important distinction. It's an intercept when it touches, not when it crosses.
Oh, okay.
Yeah. And then finally, what about this guy right here? Where are the intercepts?
0, 2.
How about 2, 0?
Oh, yeah.
Is that an x-intercept or a y-intercept?
X.
That's an x-intercept. And how about 0, negative 3? That is a y-intercept. Now I want you to look at all three of these points that we just did. Do you notice anything that the x-intercepts have in common or that the y-intercepts have in common?
0.
Yeah, they all have a 0. Be more specific.
They start with 0.
Which ones?
The Y's.
The y's always start with 0.
The X is always in the 0.
So one thing we could say is x-intercepts are always in the form number, comma, 0. Y-intercepts are always in the form 0, comma, number. And there is one special case, and you already said what it was, where you could have a single point that was both an x-intercept and a y-intercept, both also known as the origin. The origin is the only point that is both an x-intercept and a y-intercept. At 0, 0. So this next sentence I'm going to say is going to sound really confusing, but bear with me. The x-intercept has a y-coordinate of 0. A y-intercept always has an x-coordinate of 0. So the y-intercept, the y is the number that changes. The x is always 0 in a y-intercept. The y is always 0 in an x-intercept. So why are intercepts useful to us? Well, graphically, intercepts tell us some useful information because generally in real life, when you graph an actual real life situation, y and x intercepts indicate where something starts and where something ends. When we're just working on graphing, which is all we're doing, we're not getting into the weeds yet on what this is used for. We're just trying to graph it. When you're just graphing it, the intercepts are really useful because since you know one of the numbers is 0, that makes the math really simple. Let me show you what I mean.
This is what you're talking about, that we can just graph it while just looking at it, right?
Say that again?
This is what you're talking about, why we can just graph it by looking at it, right?
That will be next week. Next week I'm going to show you how you can graph it just by looking at it.
Oh,
Well, that's what you said by the end of class, we're gonna be looking at it and graphing it.
I meant by the end of class, you will be able to graph it without needing anything besides the equation.
Oh, okay.
To graph it just by looking, I wouldn't be able to graph this just by looking at it. You have to do a little bit of algebra to get it there. I'm going to show you how to do that next week. I know you're very excited about graphing. I promise. I promise it's coming. We're just not there yet. Okay, so I'm going to solve this by graphing the intercepts. Now, what that means is when I create my t-chart, I only need 2 spots on it because at most, my graph is only going to have 2 intercepts, right?
Yeah.
One of them will be when the x-coordinate is equal to 0. Which one's that going to be? Which one of my intercepts has an x of 0? That's the y-intercept. And the other one will be when y equals 0. That, of course, is the x-intercept. Okay, let's solve them. Let's start with the x first. Instead of x minus y, we're going to do 0 minus y equals 2. Look how easy this is. 0 minus y is negative y. That was nice. Went away immediately. Still a problem that it's a negative y, right? I want it to be a positive y, so what do? Divide by negative 1. So y equals negative 2. That is one of my points. The next one's even more impressive. When the y value is 0, because I'm going to do x minus 0 equals 2. What's x minus 0? X equals 2, and I'm done. 2, 0. That right there, that's enough information for me to graph it. I prefer 3 points, but we can get by with 2. We can get by with 2 in a pinch. I'm going to graph 0, negative 2. And 2, 0. And when I connect those dots, victory. So graphing using intercepts has a lot of advantages over graphing using a t-chart. Because if I'm plugging in zeros, that makes the arithmetic really, really easy.
That only happens with zeros, right?
There are other numbers you can pick that also make the math really easy, but zero is the one that like consistently makes it easy.
Okay.
Zero is almost always a good number to pick. Almost. I want everybody to remember I said almost just now. So when I give you some problems where zero is not the best number to pick, I don't want to hear a lot of griping. All right, let's try a little trickier one. Okay.
2 points on it.
Yep, 2 points. So let's do our t-chart here. And this time I don't have to worry about picking the coordinates. One of them is going to be when x is 0, and one of them is going to be when y is 0. That's going to give me my y-intercept and x-intercept. And
You just pick 0, right?
say that again?
You just pick 0?
I picked 0 specifically because I want to use the intercepts.
Oh, okay.
If I didn't say use the intercepts, you could pick any number you want to.
Oh, okay.
But 0 always gives me the intercepts and has the handy bonus of making the math easier. Watch this. Let's replace the x with 0. So 2 times 0 plus 4y equals 8. And the first part's gone. 2 times 0 is 0. And 4y equals 8. Divide 4. And I get y equals 2. So my y-intercept is 0, 2.
So it would be just -2.
Maybe. We can't tell for sure. It's not always going to be just the opposite. That was just a coincidence on the last one. I like that you're looking for patterns, though. That is the sign of a strong mathematician, is when you look for patterns. And again, look how nice it is to plug in 0 for y. The 4 times 0 is gone. 4 times 0 is 0. And I'm left with 2x equals 8. Divide 2. And I end up with x equals, no, I'm sorry, quattro is not the answer. It's actually 4.
Yeah.
This is America, sir. We don't speak Russian. So 4, 0. So when I go to the graph, the 2 points I'm going to graph are 0, 2, and 4, 0. So here's 0, 2, 2, 3, 4, 0. And then I will connect these two. Feel all right about these?